Hello, my mathematicians! Today we're going to be looking at equivalent fractions, which is a super important fractions skill. We're going to look at them with models and number lines using multiplication and division. If this feels like some review work or that you've already played with this in other extension work at home, well, it is. That's true. But I just want to make sure everybody had a good chance to get everything down just right. So equivalent fractions are fractional amounts where the amount stays the same, but the size of the pieces are different. And I put this in here for you because I just love the little graphic it gives you here. 1/2 is if I take the whole thing and cut it into 2 equal parts. So 1 out of 2 parts is blue. You can see with the fourths here, when we divide each of those halves into 2 parts, then 2/4 is equal to 1/2. And if we do it again and multiply our numbers of pieces, or our numbers of cuts, we find that 4/8 is also equal to that. And it makes sense, because 1 is half of 2, 2 is half of 4, and 4 is half of 8. So being able to find those equivalent fractions, super important. Let's do some problems here, shall we? Here we've got 2/3 of the bar is shaded. Now they've multiplied their cuts, they've multiplied their pieces. And so instead of having 1, 2, 3 pieces, we have 2, 4, 6 pieces. That changes the denominator because the size of the pieces and the kinds of the pieces have changed. And we can see that we've got 2, 4 in the numerator. Remember the color part up in the numerator? That's what you get. So let's check now on this one. On this one, it took our 2/3 and we divided each of them into 1, 2, 3. So we have 3, 6, 9 in the whole thing down here. And then 3 times 2 equals 6. So we hope you can see here that 2/3 is equal to 4/6 and is equal to 6/9. Here's another group of pictures, just something different. We keep multiplying the pieces. So if this was one piece, this time we did it times 2, didn't we? Well, that gives us 2, 4, 6 pieces total, and just 2 that are colored in the numerator. Looks like this one they started with 1/3 and they multiplied their pieces times 3. That means every one yellow piece became 3 of these little guys. So let's see, that would be 3, 6, 9. 3 times 3 down here equals 9 in the denominator. You have to multiply both the numerator and the denominators because that keeps the pieces the same size. And on this last one, they took that original yellow piece and they multiplied the number of pieces by 4. Same amount, different size pieces. Well, 1 times 4 is 4, and that represents these green ones up here. But 3 times 4 is 12, and that represents all of the pieces. Now we can also think of fractions as being on number lines. That's another powerful way to look at it. So here we have the number line starting at 0. Here's 1 over here. So this would be our whole thing. And 1 jump here is halfway. 2 jumps here stops at 1/4 and 2/4. And here we have a number line divided up into 8ths. That means this, 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 all of these are 1/8 of the whole number line. And halfway there is 4 of them. So let's look at this lovely number line here. This one is divided into thirds. 1/3, 2/3, 1 whole right there. Now let me see if this is 1/3, but now how many pieces? 1, 2, 3, 4, 5, 6. Aha! The denominator here is going to be 6ths. And so if I put the 6 in the denominator for all of these, you'll have some practice pages that has this. So now we're dealing with 6ths, and this would be from 0 to 1, 1/6, 2/6. This would be 3/6. We've got 4/6 and 5/6. Now, then we get to 1 whole, although I'm going to take this opportunity to remind you that 1 can also be written 6 out of 6. Down here, it looks like we're dealing with 9ths again. So this starting from 0 would be 1/9. This one over here that is equal to 1/3 and 2/6. Well, 3 times 3 is 9. So 1 times 3 is 3. This would be 4/9 and 5/9, 6/9, 7/9. So that's how you use number lines to think about fractions. Just some different ways to do it. This is the one I love the best, and I bet you do too, is that we can use multiplication and division to help us find equivalent fractions. Now they've got a nice model over here showing us. They took a strip of paper and divided it into 7 parts, and they have 1/7. Then they multiplied their parts by folding it in half again. That's like going times 2. It's the same amount of stuff. 1 times 2 is 1. 7 times 2 is 14. Same model over here. This time, they multiplied the number of pieces by 3. Okay, so let's use multiplication for that. We start off with 1/7. 1 times 3 is 3, and 7 times 3 is 21. So we could say that 1 times 7 is equal to 2/14 and 3/21. Look at that. So we'll just do a little practice here. You'll notice that, here we're going to use division. And if you watch my simplifying fractions videos, I said to just divide by 1 by dividing 2 halves. You can see they've kind of split it apart here, but that's how we would simplify fractions. So if we start with 4/12, we divide both the numerator and denominator by 2. That's like taking the cuts out. It's magically uncutting it. So let's see. 4 divided by 2 is 2. 12 divided by 2 is 6. I'm down here to 2/6. Then over here I said, 4 and 12 share another common factor of 4. 4 divided by 4 is 1, and 12 divided by 4 is 3. So here are 2 different equivalent fractions for 4/12. But if you've been playing on Painting with Fractions with me, you know that we really care that we get the simplest form. Teachers love it when you use your equivalent fractions skills to get into the simplest form. So that's how you do it.